Hello friends, welcome to Truth of Physics. Today in this video I will discuss on how you can make a peak detector circuit. Now what's a peak detector circuit? In many cases in electronics you will have to find the peak of your given input signal. Suppose this is the given input signal varying V input. Okay, then after this, suppose after this point the circuit is cut off or the circuit is turned off, then there will be no V input after this. Okay, then you have to find the peak, the last peak. Then you can see that here this is the peak, right? Now how you can make a circuit, design a circuit which can detect your peak of the circuit, that I will discuss in this video. And first I will discuss a very simple circuit. Okay, then I will discuss the drawbacks of the circuits and how you can make or improve that circuit. Okay, so first let us understand the simplest peak detector circuit, which is like this: for a diode, okay, PN junction diode, whose forward diode voltage drop is 0.7 volt, suppose, then a capacitor, and then it is grounded. Okay, now if you take a V output from this point with the ground, then V output will tell you the peak. How? Let us understand that this is V input. Then as the V input is greater than V 0.7 volt, then what will happen? Then here at this point, what will the voltage at this point? The voltage at this point will be equals to V in minus 0.7 volt, right? So because this 0.7 volt drop is because of the forward voltage drop of the diode. Okay, so the V input will be like this. So here at this point the V output will look like this, V in minus 0.7 volt. So the V output will look like this up to this point, right? Up to this point. After that what happens? Let us understand that. So up to this point, this is a PN junction diode, means this will allow you only to flow the current in one direction, right? It will allow you to flow the current only in this direction. When it is forward bias, when the V input is greater than 0.7 volt, then this will be like a short circuited wire. Then what happens? The current will only flow in this direction. But suppose, let us understand with an example, that suppose here this peak is at 5 volt, suppose, and here this point is at 4.5 volt, suppose. Then this voltage was at 5 volt first, then it comes down to 4.5 volt. Then what happens? Then the capacitor was firstly charged, the capacitor will start to charge, okay, and it will charge up to 5 volt. Charge means what? The current is going in this way, and the capacitor, this plate, will gather charges, positive charges, and as this plate is grounded, so this will be always in 0 volt. So this plate will be charged accordingly the V input. So at this point, at this moment, the voltage at the upper plate will be 5 volt. But after that, whenever the voltage at this point will become 4.5 volt, then what happens? This point is 4.5 volt and this point is 5 volt. Then you can think that, and after that the V input is going downward, that means after that the 4.5 volt will again drop down. Then this point is higher voltage and this point is lower voltage. But you can think right now that the current will now go from higher voltage to lower voltage, like this way. The current will now flow in this way, that is, we simply call it the discharging of the capacitor. The current will flow in this way. But there is a PN junction diode which will not allow the current to go in the opposite direction. That means the current will not go in the opposite direction even when the voltage here is lesser than 5 volt, and it will gradually decreasing. But then also the capacitor will not discharge. So the capacitor plates, this plate's voltage will retain at 5 voltage. Okay, as this is not discharging, so it will be at 5 volt all over the period, like this. Whenever the voltage again rises from this point, right, then it will be like this. Whenever the voltage rises from this 5 volt, then it again starts to charge to the next peak, and then the repeated process will occur, and whenever this will go downward, the V input, then it will again store the charge, okay, and then same the case it will. So now if you can think right now, if after this the circuit is off, then the output, this was our output, then V output will give you just what, just the voltage of the last peak of the peak, right? So it is what, it is tracing the peak. Actually the V output is actually detecting the peak of the V input. So thus in this way this circuit will work, the peak detector circuit. Now there are several drawbacks of this circuit. What are the drawbacks? The first drawback you can see there, that V output is this and V input is this. Now there is a major problem, that is there is a voltage drop of 0.7 volt, right, due to the forward voltage drop of the diode. So the actual peak is not detecting by the V output. The actual peak is this, not this, right? So it is not detecting the actual peak. The number one drawback. The number two drawback is whenever there is a peak, when it actually this circuit's impedance is changing. It is a variable impedance. There is a variable impedance of this circuit, and whenever there is a peak in the V input, then the circuit's impedance, input impedance, is very lower. This is the second drawback. And the third drawback is the diode's forward voltage drop 0.7 volt is dependent on temperature also. As temperature increases, the diode's forward voltage drop will change, okay. So that will also give a negative effect of the V output to detect the peak, right? So this type of inaccuracies, you can overcome this type of inaccuracies with the help of an improved circuit, which I will discuss in the next video. So hope this video is very much helpful, how you can make the simplest peak detector circuit. In my upcoming videos I will discuss how you can improve these circuits, okay. Several circuits are there to improve this type of faults, okay. So share this video with your friends, and for getting the notifications of conceptual classes on physics on various topics, subscribe this channel and hit the bell icon. So take care of yourself. Thanks for watching.